All right, so welcome to session 3AC here at the GSE UK conference. This session is GDPS interfaces, a modern approach for managing your high availability disaster recovery on mainframe. For a second, I forgot what DR stood for. How dreadful. Okay. So this is session 3A. Please remember to fill in your feedback at the end so that we can understand where we maybe have to fix things for another year. We do look at your feedback, so please do provide it. The session today is presented by Anthony Morales. And Victor Tadu is also here because as well Anthony has been having some bandwidth issues, so just in case there's an issue there, Victor is prepared to jump into the session. Okay. This year we are supporting two charities. The charities are the Guide Dogs for the Blind and the RNLI, the Royal National Lifeboat Institution, who, both organisations do excellent work, and we are hoping to be able to give them quite a good donation at the end of the conference. So if you could show your appreciation for the presenters by giving generously, and also you will get an entry into the Guide Dogs for the Blind, an entry into the raffle for each pound that you donate. You will get a receipt for your donation. Okay, so without further ado, I'll hand you over to Anthony, and good luck.
Okay, thank you, Anna. So good afternoon. Team, and currently located in France. I'm going to give you an overview of GDPS and the different interfaces that are available to operate and monitor it. So please don't hesitate to take questions in the chat as we go through. As Anna mentioned, Victor Tardieu is also here, and he will help me take questions if needed. So GDPS, which is a continuous availability and disaster recovery solution, can be managed manually with different types of user interface or programmatically with APIs. And we are going to take a deep dive into this interface. So first, before going into much detail into this interface, I am going to give you a brief overview of the GDPS product family and see what functions it offers and what problem it addresses. Then we're going to have a look at the existing interface allowed to operate GDPS. And more particularly in this session, we are going to have a look at the graphical user interface and the RESTful API. So first, let's start by having a quick overview of what is GDPS and what does it offer. There are different events that can justify the need for a continuous availability and disaster recovery plan. And for all these disaster scenarios, there is a GDPS solution that provides an answer. In the case of a global disaster striking and affecting a large area, it's important to be prepared and make sure you have a safe and consistent copy of data, and also have procedures and an infrastructure ready to be able to restart the production as soon and as safely as possible. In the case of a local disaster that may occur on a smaller area or even on a single component of the IT infrastructure, it would be preferable to have a solution in place to work around the failure and avoid disruption of service. In the case where interruption is inevitable, then again, you need to have a disaster recovery infrastructure as well as recovery procedures to be able to resume the activity. And finally, last but least, there are also maintenance scenarios. That's a kind of event that is going to happen more frequently than the two previous ones. For instance, upgrading a hardware component such as a disk bay or updating a piece of software, for instance. These activities must not be disruptive, and they must not lead to the introduction of rolling problems and failure during the maintenance scenario. So this is why GDPS is offering this solution. These are all the GDPS solutions that exist. Each of these solutions address different needs depending on several aspects. This one is the topology of the data center. What's the distance between your site? How many copies of data do you need? And so on. The other important aspect is the objectives in terms of RPO and RTO. So to make a quick summary, the RPO is the maximum targeted period in which data might be lost from an IT service due to a major incident, and RPO stands for Recovery Point Objective. So it's basically how much data am I ready to lose in the case of an outage. The RTO, which stands for Recovery Time Objective, is a targeted duration of time within which a business process must be restored after a disaster. So basically, how much time am I ready to suffer from an interruption of service? So if we look at all these solutions from left to right, GDPS Metro HyperSwap Manager offers a single data center continuous availability solution. It offers an RPO of 0 because it is built on synchronous data replication and therefore no data loss. Now, if we look at the right, GDPS Metro is a disaster recovery and continuous availability solution for metro distance data centers. So in addition to the synchronous replication and hyperswap offered by GDPS Metro HyperSwap Manager, it also provides automated disaster recovery procedures to control disk as well as servers. So those are the two continuous availability solutions in GDPS for metro area. Now, if we look at the solution for extended distance, GDPS Global is a disaster recovery intended for data centers separated by an unlimited distance. Because of the distance, this solution do not rely on synchronous replication, but instead on asynchronous replication, making the RPO a little bit higher than GDPS Metro. So the intent is to provide automated disaster recovery procedures in order to restart operations on the disaster recovery site in case of an incident on the production site. And then we have 3 and 4 site solutions. For instance, GDPS Metro Global combines GDPS Metro and GDPS Global to provide local continuous availability and disaster recovery on a distance DR region to recover from in the case of a large incident on the production region. So as I said, it supports 3 and 4 site configuration. And we'll see that in the next few slides. And finally, at the far right of the slide, we have GDPS continuous availability, which offers continuous availability at extended distance, thanks to a completely new approach using software replication rather than hardware replication of GDPS solutions. So this replication is asynchronous because of distance, but it supports a zero data loss feature where GDPS continuous availability introduces an extra layer of synchronous replication in order to offer zero data loss. So we'll not go into details into this presentation, but it's good to have the full picture before going into the detail of the interface. So we just saw that GDPS Metro provides continuous availability thanks to the hyperswap and local disaster recovery. Because of the technical limitation, such as latency induced by the synchronous replication or cross-site coupling facility communication, the distance between the site in the GDPS Metro solution is limited. On the other end, we have GDPS Global GM, which offers potential unlimited distance between the two sites, but only offers out-of-region disaster recovery, does not provide continuous availability. So in order to benefit from both local CA and remote DR, GDPS Metro and GDPS Global GM can be combined. This solution is called GDPS Metro Global GM. So if we look at this picture, on the left-hand side, we can see that we have a production region with two sites, A and B. Data of site A is synchronously replicated to site B, and we have hyperswap capability between these two sites. But now we also have a cascaded global mirror session between site B and site C, which is a disaster recovery site outside of the region. This global mirror session is managed by GDPS, and a GDPS remote controlling system is in place on site C in order to be able to restart LPARs on the disaster in case of an outage or maintenance on the production region. So we can see on the left side picture that GDPS supports a cascaded configuration where the application goes from A to B to C. But we can see on the right side that it also supports a multi-target configuration where the replication goes from A to B and A to C. The cascaded or multi-target mode can of course be used as needed for the same GDPS license. For instance, multi-target can be useful to restart replication after an hyperswap without having to suspend the global copy relationship. So now we are going to talk about four-site solution. So we just saw that GDPS multi-site support 3 sites, where we had 2 sites on the production region and 1 disaster recovery site outside of the region. But we now have the same capacity and the same level of availability on both regions with the GDPS 4-site solution. On region 1, we have 2 sites, A and B. A is synchronously mirrored to B. Then there is global mirror replication going on from region 1 to region 2, once again, either cascaded from B or multi-target from A. Then on the region 2, we also have 2 sites, C and D. The GM session goes from region 1 to site C on region 1. And in region 2, we have Metro mirror replication going from C to D. The slight difference is that because C is a GM secondary, the replication going from C to D is not synchronous. It's also known as PPRC XD. So we now have a fully symmetric configuration where the data is replicated from region 1 to region 2, or vice versa, depending on when the production is running. And it is much easier to switch regions. GDPS Global GM for site offers automated procedure to switch the activity from one region to the other and go back. Now, if I switch and start my LPARs on region 2, I have GDPS Metro capability, so I have hyperswap. So I have the same continuous availability capabilities as on region 1. So it means that I can safely continue to run this way without the urge to switch back to the production region, and it makes it easier to do more frequent region switching for disaster recovery, test and validation. Then I talked a little bit of GDPS continuous availability. So this solution was born to respond to a specific need for a specific customer who needed more than what was offered by GDPS Metro Global. So the need was that the sites are separated by a very long distance, making GDPS Metro not relevant for this situation. Both sites are running the same application and therefore work with the same data. And the solution needed to be able to provide cross-site workload balancing to route or the other. So this approach allows to leverage the existing infrastructure on both sites and provides continuous availability. And this continuous availability, unlike GDPS Metro, is at unlimited distance. Of course, the solution also offers disaster recovery because the distance between the two sites is practically unlimited. So we can use the secondary region as a disaster recovery region. So this is a new concept that GDPS brings with GDPS continuous availability to respond to this customer need. So to summarize the concept, we have our two sites separated by a long distance. On each site, there are a few workloads that are running, processing the same data again. And between the two sites, there is software replication going on. So this is a little bit different from what we had with GDPS Metro. With the previous GDPS solution like GDPS Metro, the replication was done by the hardware itself, and the tracks of the disk were copied. With GDPS CA, we do not use this approach, but instead we rely on IBM InfoSphere data replication, which will capture the workload transaction on one site, send it over to the other site where the transaction will be replayed with a capture engine. So you have with the apply engine, there is a capture engine on the production site, capturing the transaction, sending it to the disaster recovery region with MQ, and replaying the transaction there. So basically the workload is active on one side where it's production transaction, and standby on the other side where it replays the transaction. On the other end, we have workload transactions that are routed to the active site, the workload distributor, which controls a switch which implements the SASP protocol. So we rely on IBM workload lifeline, which is doing the transaction routing. And this way we have one active site and one standby site, and we are able to switch transaction on one site or the other. So if needed, the workload distributor, so workload lifeline, can route the workload to one site or the other.
Anthony, we have one question in the chat. How many 4-sites GDPS customers are there out there, if you know?
I don't have the specific number, but we have more and more GDPS 4-site. Basically, all the largest banks are switching to this kind of solution. So the question is, are you cutting edge by going to a 4-site solution? The answer is no. There are already plenty of customers using 4-site solutions. So we just saw the different GDPS solution that exists very briefly. And now for the purpose of the presentation, I want to take a deep dive into the existing interface. So there are several interfaces that exist to control and operate GDPS, and we are going to see different use cases using these. So the historical user interface for GDPS is the Telnet 3270 interface running in NetView. GDPS relies on several components, such as NetView and system automation. And the classic way to access GDPS panel is through NetView. From this interface, the GDPS operator can get status about the environment managed by GDPS, the status of the systems, for instance, the sysplex related information, your CDS configuration, status of your coupling facility, and so on. And also GDPS specific information, such as the status of the data replication, the status of the hyperswap, and so on. This is the interface where you control your whole GDPS environment. From this interface, you can also perform actions such as managing your disk replication, run disaster recovery scenarios, and so on. So this is really the dashboard and the operation where you control for GDP. So a few years ago, with GDPS 3.14, we introduced a new graphical user interface, which is a web browser user interface. So you access it from your favorite web browser, and it was all of the NetView interface and more in a more user-friendly and modern interface. So the intention with this kind of new interface is to lower down the complexity of GDPS, which is delivering more and more function, and it's getting more and more complex as we put in new function. And this is the case, as you just saw, with 4-site configuration, which are getting more and more complicated. So the idea is to bring a more intuitive user interface that will bring down the learning curve for the new people stepping into GDPS and stepping into the mainframe. So the mainframe skills are more and more difficult to get, and it is important to simplify and modernize the way IBM Z products are used to help our customer bringing in people into the Z platform. Then there is a third kind of interface that GDPS provides, which is a programming interface through its RESTful API. So in this presentation, so before going into our scenario of operation using the GUI and REST API, let me talk a little bit about the architecture for those who already know GDPS and are wondering how to install and how is architecture, the GUI and REST API. I'm going to talk a little bit about it now. So the GDPS GUI and REST API are using the same code. So we can talk about, when I will say GUI or REST API into this presentation, I am referring to the same component. It's basically the same component on the same code base and on the same application server. So from an architecture perspective, they reside on the same component, and we'll see that we'll see how they fit into the existing basic GDPS architecture. So in picture, this is a typical GDPS metro configuration, 2 controlling systems. Each GDPS controlling system reside in a dedicated LPAR on each site, and they both have NetView running. So as I said, GDPS rely on several components, and NetView is one of them, and I would say the most important. So all the GDPS core inside NetView, and the GDPS GUI and REST API is composed of several additional components on top of the classic GDPS implementation. So the GDPS GUI application server relies on Liberty ZOS. On each GDPS controlling system, there needs to be a Liberty server to support the GUI and the REST API. This component is composed of 2 started tasks. The first one, which we'll see here listed as GeoSRV1, is the Liberty application This is where the API and the GUI code is running. STC will listen on an HTTPS port to provide access to the GDPS interface through a web browser or a REST API client. Then you have a second started task called the angel process, and is required to allow the first one, so the Liberty STC, to access authorized commands such as authenticating users through SAF and
I think we may have lost Anthony. Do you still hear Anthony, or am I the only one not hearing him?
No, me as well. I can't hear him. I did. I was about to send you a message, but you broke it.
Yeah.
Are you able to share the same presentation?
Yes, I am. Yeah.
Point? Perfect. So if you just share.
So do you see my presentation right now?
We can indeed, yes.
Okay. So as Anthony said, the GPS GUI and the RESTful API server relies on Liberty for COS. So we need one Liberty server on each controlling system. So in the case of disaster, on one system, you still have one Liberty up or ready to be run to support the interface. This started task, so the Geo server 1 that Anthony told us about runs the GUI application code. It listens on the HTTPS port. So it provides access to the GDPS interface through the web browser, as he said. And you can also use it with the RESTful API client.
I have a question.
Yep.
There's a question in the chat from Alex. He just asked, does Liberty need to run on the same LPAR as the cases?
Yes, it does. Yeah, it's for a security reason. You need to have the Liberty running on the same LPAR, only so that GPS knows that this Liberty is a known Liberty, and we don't allow access from some Liberty that is not known by GDPS to access GDPS information.
Okay, thanks.
So there is another starter task that is called the angel process, and this starter task is required to allow this first started task, the Geo server 1, to issue authorized command such as authenticating users with SAF. We'll see in a bit later in this presentation that some SAF customization is required to set up this true starter task. So then on the NetView side, there is also an additional component, which is called the GDPS NetView daemon. This is a NetView auto task that is providing access to the GDPS data and functions. To set up this component, a new NetView operator needs to be defined, as well as corresponding system automation function. I see a question in the chat.
Yeah.
TOT incompatible with iPage and the key system. Then. So you can, you can set up the Liberty to listen on different set of ports. There is 2 customization files that you need to set up. One on the Liberty server directory, and to set up the HTTPS. And then on the GDPS side, we have a geo group configuration file where we set up the ports. So yeah, it's compatible with any other application that would run on the controlling if you set up different ports. I hope I answered your question. Okay, so so as I said, there is some new NetView operator that needs to be defined, as well as corresponding system automation function. When they are defined, GDPS will automatically start this operator during the initialization phase of GDPS. The operator will run the command vpcu daemon, which is a module provided with provided in the sgdp exec library, and it will wait for the commands coming from the Liberty server. So they both will discuss between each other, and the TCP/IP ports that are used by the GDPS NetView daemon, as I said, to answer your question, are defined in the geogroup configuration file. So you will be able to find more information on how to install and set up the GDPS GUI and RESTful API in the corresponding customization guide of your GDPS flavor. During the next 2 slides, we will see a very high level of the steps required to install and configure the GDPS GUI. I see that Anthony is back. Anthony, do you want to pursue, or should I pursue?
I'm going to ask him to unmute, and then if you carry on, he can also break in and talk, or just take over and you can run the slides. Either will be fine.
Hello, I'm back, sorry. Can you hear me?
Yes.
Yes.
So Victor, do you want to go on, or?
It's up to you, as you want, really.
Okay, go on. I will jump in if needed.
Okay. So the GDPS GUI/RESTful API are shipped in the FMID JGDP 4XB. It depends. The X depends on your GDPS version, and we have 3 components. We have an embedded Liberty ZOS. This is the Liberty server and the Angel process that GDPS will use to run the GUI. It's installed under the USS and in the path that is written in the gray box on the left. But the reason this box is gray is because since GDPS 4.4, we do not provide this Liberty, because GDPS 4.4 prereqs ZOS 2.3, and ZOS 2.3 has its own Liberty that is embedded with it. So we decided to use this embedded Liberty instance instead of providing another Liberty. In the middle, we have the GDPS GUI REST API code. ZFS during SMP installation. And finally, we have GDPS Rex execs in order to support the GUI. There is a few additional Rex modules that are delivered, and they are also they are installed in the SGDP exec library. So once the SMP installation is complete, there is a few steps required before being able to use the GDPS GUI. The first one is to set up a new automation operator in system automation. This SA function, so the SA function with it is GeoWeb UI, and the associated operator is AUT Web UI. The profile definition for the NetView operator is predefined in GDPS in the member GOO-PFG1 in the DSC PRF concatenation of NetView. You will also need to customize the geo group in order to add the information relative to the Liberty server. So you will define the IP address of the Liberty server, as well as the port used by the GDPS NetView daemon to communicate with Liberty. The third step is to customize the Liberty STC, so the Liberty started task. GDPS will provide a sample STC in the SGDP SAMP library, but it will need to be customized to match with your environment. For instance, you will need to provide the path to the Java, and you will also be able to customize the Liberty output directory for log files, for example. There is also some configuration to do on the Liberty server itself. This configuration is done with the properties file under the Unix system services. This file is called bootstrap.properties, and in there you can specify the port that are used by Liberty for HTTP or HTTPS, and also you can, if you want, you can define the key store for SSL. Finally, as we mentioned earlier, there is some SAF definition to make in order to allow the Liberty server to run authorized operation, and also to define which users will be granted access to GDPS GUI and RESTful API. So let's have a deeper look at the GDPS graphical user interface. There is multiple objectives with this interface. The first one is to provide an easy to use and intuitive user interface. IBM-Z platform and GDPS solution evolves during years, and it is more and more complex to maintain this environment. So with the ZS, and also with the Z skills getting more and more difficult to find, we find important to simplify and modernize IBM-Z product. This is why GDPS GUI provides an easy to get people on board without having to have extensive ZOS skills. The interface of the GUI is a web-based applications that is served through Liberty, running on ZOS, and the GDPS GUI is functionally equivalent to the NetView 3270 interface. So you have all the same function, but you have all the advantage of a modern web interface with the GUI, and you have some functions that are not available in NetView that are available in the UI of the web UI, such as automatic panel refresh, filtering capabilities. You can open multi panels at the same time. You have some notification with pop-ups. On top of that, the GDPS GUI offers a single point of control for GDPS operation. You have some functions that are not available in the NetView, but are such as TSO operation, and they are available in the GeoParm. They are available in the GUI. For example, you can manage your GeoParm, you can manage GDPS options, scripts, you can analyze syslog. So during the next slide, we will have a deeper look at these panels, and we go through one scenario, which is the maintenance on hardware maintenance on the site 1. So GDPS can simplify and automate your HA disaster recovery operation. So we're going to run together a DSS disk subsystem maintenance scenario using the hyperswap through the GDPS GUI. So in this picture, you see the GDPS main dashboard. It is the first panel that will be displayed when you log into your GDPS environment. So you have different status on it. You have a precise view of the health of of all the components managed by GDPS. We can see that we are logged on GDPS Metro. On the top left, we see Metro 4.3. environment. We can see that we are this is a single leg environment with the topology MM2 site. Both on site 1 and site 2, we have systems and storage. Just so you know, the warning that we see under the DSZK, under the systems view here on the left and on the right, indicates that not all the GDPS managed systems are up and running. There is a lot of reason for that, intended or not. Here, this screen capture has been taken on a development environment, and many of our systems are used by different developers. So don't focus on this exclamation point. They are intended and expected in our case. So on site 1, we can see that we have 2 disk subsystem. This is integrated with the little this little badge icon at the bottom of the DSS icon. We have the same kind of information on the site 2 on the right for system and storage. And between these 2 sites, we have an indication of the status of the data replication. So in GDPS, the group of volumes that is going to be replicated and managed by GDPS, it's called a consistency group. And this consistency group is defined in the GeoParm, which is a XML configuration file that contains all the replication definition of your environment. So in our case, we have a consistency group that is called prod, and there is a green arrow going from site 1 to site 2. This gives me the information that the PPRC replication is going from site 1 to site 2. And since it's green, it means that all my device pairs are duplex. So at this point in time, all my systems are running using the storage in site 1, and the data is synchronously replicated to site 2. If we're looking at the bottom of the screen, we can see the health overview here. And this section gives me additional information about the health of my environment. In this particular case, the hyperswap is check mark green, so it's enabled. Same for the DASI mirroring, so it's okay. The DASI mirroring is okay. So we are in good shape to run our maintenance scenario. The intent is to swap system activity to site 2 in order to apply maintenance on our site 1 storage. So to do that, we are simply going to run a GDPS script. So on the left, we have a menu. When you hover the script icon, you can see planned actions. And if we click on planned actions, it opens the scripts management panel. So this is the panel where you access all the GDPS script available that you have defined in one of the configuration files. You can run with the scripts, you can be prepared for many HADR scenarios, such as hardware maintenances, data center maintenance, unplanned site failure, and so on. So in our case, we want to apply maintenance to our storage site, our hardware in site 1. So to do that, we're going to run an hyperswap to site 2 in order to make our system use the site 2 storage and make our site 1 DSS available for maintenance. We have prepared a script for this specific operation, and we're going to use it. His name is hypersus. So if I type in the filter bar at the top hypersus or just hype, I can find my script, hypersus. It's a script that contains that is used to execute an hyperswap suspend scenario, and that's exactly what we want to do. So if we click on this script, we can see the script we selected, and it's very simple. It is composed of only one step, which is an hyperswap suspend. So this step will swap the system I/O to site 2 and suspend the PPRC mirroring. So just like this hyperswap statement here, GDPS proposed a lot of other script statements in order to automate a lot of procedures. For example, we could have selected a site failure script, which would have included system shutdown, IPL on the other site, reconfiguration of coupled datasets, relocation of coupling facilities, structures, activation of capacity on the disaster recovery site, also reconfiguration of SCP role, and so on. There is a lot of possibility with scripts. And all that can be done with one single script. But in our scenario, we're just going to run one planned hyperswap. So we can see on the screen that before allowing to execute the script, the GDPS will do some validation. So that's why we see the status available at the top of the pop-up. It checks that everything is in good shape before proceeding. Here, for example, it will check that all pairs are duplex, that no other GDPS operation is ongoing, and any other checking is needed. So here it's available. We can proceed by running by pressing the button running from step 1. So now that the script is launched, we need to follow the execution on the SDF alerts panel. So this status display facility, SDF, is where GPS will post messages relative to the execution of the script. So on the exclamation icon in the menu, we have the SDF alerts button that is available. And if I click on it, it opens the SDF alerts panel. So at the top, we see our script name, hypersus, that was started from step 1. And we can see the first step, switch hyperswap suspend leg that is started. And the following message will follow. As the execution goes, we see new message coming up. One interesting one is the GO950I, which is interesting during an hyperswap because it gives us the user impact time. The user impact time here for our hyperswap was 5.25 seconds. So the user impact time is the time between the beginning of the processing and when the IOs were resumed. A bit further down, we can see all the autonomic processing that GPS does in the context of an hyperswap. For instance, we can see here with this message that soft fencing of the former primary device were done to avoid unexpected writes on these disks and preserve data consistency. Also, we can see that GDPS will automatically change the IPL modes for all GDPS managed systems. This is done to set up for success any subsequent IPL from the GPS panels and make sure that we are IPLing the systems on the right disks. And at the end, we can see that the hyperswap planned standard action ended, and in particular above that our step hyperswap suspend on the leg 1 ended with a return code of 0, which means that it ended correctly. If we go back to the dashboard, we can see that the arrow now showing the replication has changed direction. Our systems are now processing IOs on the DSS located on site 2. Our replication goes from site 2 to site 1, so from site 2 to site 1. But since the arrow is now red, it tells us that our device pairs are not duplex anymore. But this is expected, right? Because we just performed an hyperswap suspend, and it means that the replication is suspended. We can now apply the required maintenance on our storage unit on site 1 and resume mirroring when it's done. So this was just an example of a scenario that you can run for a specific situation, but there are many other cases where you could use GPS and the graphical user interface to manage your high availability and disaster recovery. You can do planned site maintenance with IPL on the other site. You can take point-in-time copies of production data for cyber protection with LCP, for example. You can take standalone dumps on system and many other things. So we saw an example of what you can do manually with GDPS through its user interface, but you can also run operation or query information from GDPS programmatically using the RESTful API. So what's a RESTful API? REST stands for Representational State Transfer, and it's a standard in terms of data exchange based on the HTTP protocol. Since it is based on HTTP, it is using the base HTTP request methods such as GET, POST, PUT, or DELETE. A REST API is a programming interface, as in API, and it's based on this REST. It's based on this standard. The power of the REST approach is that it's largely used and easy to. It's a largely used standard. Sorry, so it makes it robust and easy to use and maintain. A large number of tools and products are natively supporting REST, either on the client side or the server side. As we just saw, REST is largely used, and IBM, as well as other many companies, are basing their APIs on this standard. An example of REST API provided by IBM, we can name ZOSMF, who is providing a few REST services, ZOS Connect, IBM Cloud, or even the Weather Channel, who is providing weather data through REST APIs. IBM is not the only company using REST APIs. Of course, many others are relying on it, such as Amazon with AWS, Google, or Twitter. From the definition we saw earlier, a REST API is an API, so a programmatic interface that is reached through the HTTP protocol. A REST service is a particular function available through the REST API, and there are several things that define a REST service. You have a description, you have its URL, which is the relative path to the service from the API application server. You have the HTTP method to access it, either GET, POST, PUT, or DELETE. You have a bunch of parameters and a type for each parameter. Sorry. We have a type for each parameter. You can put this parameter in the header, in the request itself, in the HTTP body. It can be a string, a number, a JSON object, and so on. A REST service is also defined by its return codes that the service can send back. In REST standard and HTTP standard, it should return 200 for successful requests. You have also 401 for not authorized, and 404 for not found, 500 for error in the server, and so on. And finally, the data that is sent back from the service and its format also define the service. On this slide, we have an example. It's a REST service from the Weather Channel. It returns the current weather condition, and so we have its URL /turbo/VT1 observation. The method, which is get. We have 4 query parameter: geocode, units, language, and format, which are query parameters, and 1 header parameter, which is accept encoding. They are all strings in this example. If we look further down in the service description, we see that for 200 return code, it will send back a response body in a JSON format with various fields about the weather situation, humidity, wind speed, barometer, and so on. You can call REST services in different manners. Because REST is a standard, it's largely used, and there are a lot of REST clients available out there. Curl here is a popular command line interface for testing REST services. In this slide, we see an example of a call to the weather REST service we just saw with curl. We have curl, the method, the path, and the parameters that follows, either in the query on the left or in the header on the right. So why do we provide in GDPS a RESTful API? In GDPS, we already provided other programming interfaces that were existing for a few years. We had query services, GCI, GDPS console interface, and we're going to see in the next slide what is the advantage of this RESTful API compared to these two already existing API. The GDPS query services are API that allow to query information in GDPS using the VPC query netview command. As the name indicates, it only allows the user to query information and do not provide a way to run actions against GDPS. So it is a very and moreover, it is a very platform and language oriented API, since it's called through a netview command. So it can only be launched from netview, and the automation that is built around this command is limited to the language available in netview, which is mainly Rex. The other API is the GDPS is GCI. It's available through write to operator messages, WTOR. It provides the capability to run queries and actions on GDPS, but the drawback is that the number of functions available through GCI is limited, and not all operations are available in GDPS panels. Not all operations that are available in GDPS panels can be done with GCI. It's also platform oriented because it uses WTOR, and the usage and the automation built around GCI has to be done on ZOS only. From a language perspective, only the language supported on the mainframe can be used, and moreover, only languages that allow to respond to WTORs. So very limited limited API. So the RESTful API erases all of these constraints. First, it allows both queries and action on the GDPS. All the actions and data available on the GDPS user interface are available through the RESTful API. Since this REST approach is based on HTTP protocol, any client, even outside of the mainframe, can use the GDPS RESTful API, including ZOS. You can have a mobile client, a Windows machine, and anything that you can think of. From a security perspective, the access is limited to user only. Well, it's limited to users authorized to the Liberty server through SAF only. And because the client can reside in any platform, the number of languages that the API client can use is almost unlimited. It extends the scope of possibilities for GDPS customers that wants to build more automation and tools around GDPS based on the skills available in their teams and not only limited to ZOS. Internally, we also use this RESTful API for regression testing in GDPS and some other tests. So I don't know, we've reached the top of the hour, but I have some other slides remaining. Should we pursue or?
Can we have some sort of show of hands if we should continue? Okay, so we have a difference of opinion. Some people want to continue and some people want to leave. So anybody that doesn't want to stay on, feel free to leave and go to the lunch and learn sessions. If you're happy to stay, then we can continue whilst there's people still on.
Yeah, so just so you know, in the next slide, we'll see an example of how we can use the RESTful API to automate a process following the scenario that we've done with the graphical user interface. So just you are aware of what's next.
Yep. So please make a choice, and then we will just continue. I mean, you know, make the choice to leave or stay, and we'll continue. Just for those that are leaving, please remember to do your feedback. I think it's question 5 that talks about the length of the session. That may require some response. And don't forget to donate to the charities and to leave feedback. Yes, covered that already. Okay, thank you. And thank you, Victor and Anthony, for providing the session. Okay.
Okay.
So we just got a question.
Oh, sorry.
Is the REST API running in the Liberty server or direct into GDPS stroke NetView?
I don't know, Anthony, if you want to respond or you want me to
Actually,
respond.
has responded in the chat. It's running in the Liberty server. Okay, so continue now. Anybody that isn't going to a lunch and learn.
Okay. So I will make it quick then.
Well,
so
it will all get recorded anyway, so
yeah.
people can come and listen to that part again.
So let's just take the example of our maintenance that we've done before with the GUI. So we ran an hyperswap suspend, and our system are now running on site 2, and the disk replication is suspended. So let's just say we have finished our maintenance operation on our storage on site 1, and we are ready to resume the replication. So we are going to do this with the RESTful API. So in order to resynchronize our device pairs, we are going to use another GDPS script, and more particularly the start secondary script statement. This script statement allows to reestablish mirroring between all devices managed by GDPS after the replication has been either suspended or deleted. We can see that this service is accessed during using the HTTP post command, and the URL is /planned action /execute planned action here. It takes 3 parameters: an HTTP header parameter, domain. This domain will be the NetView domain of the GDPS controlling system in which we want to execute the script. We have a query parameter, script, which will be the name of the script we want to execute. And we have an optional parameter that is step. It is used for choosing which step we want to begin the script with. By default, if we do not provide the step argument, it will start at the beginning. We can see in case of a return code 200 that it will return a return code and a message explaining the reason of this return code. So based on the description of the API, we will run our start secondary script using this REST service. I have coded, we have coded with Anthony a program to automate the device synchronization using this API REST service. Compared to using the GUI, we have a fully automated process here. It can run all the steps that we've done manually and do all the checkings we carried for this scenario. So it will use a script already defined in GDPS called start sec. It's going to start. It's basically going to do a start secondary. We will provide all the parameters required by the API service in our program, and we are showing here the high-level description of the program. So at first, we're going to start the script with. We're going to start use the API services to run the GDPS script. We're going to, once it has responded, we're going to check that the return code is 0, so that the script was successfully launched. If that's the case, we're going to monitor the SDF trace entry to check if the step itself is successful. So we're going to retrieve the SDF trace entry, retrieve the execution status inside, and if it's finished, then we know, and that the return code is 0, then we know it's successful. But we will just print the message in the log with the return code and the message and the SDF trace, and send an email to the operating people. So the operation team when the maintenance is complete. Here is the detailed code showing the part of the program in Python, which is calling the planned action REST service. So it will be this first run start secondary script that we saw at the top. We can see all the things that we've defined previously and we've talked about. We see the URL, planned action, execute planned action. We can see we are using a function to process the get request with the parameters, the script name, in the query parameters, the domain name in the headers, the certificate here for client-side certificate authentication. If we have no issues, either HTTP issue or exception in our code, we retrieve a response. We parse that response, which is JSON formatted, and we check the return code inside this response. If it's successful, we print it was launched successfully, because here we're just checking the launch. And if there is a return code different from 0, we have a HADR error. And as I said, usually the message will describe what's the error. So we print that also. This is an example of the output of our program in the command line. So we control the success of the script launch and monitor the execution in SDF alerts. Based on the SDF trace, we determine that the program determined that the execution was successful, and it sent the appropriate email to the operation team. If we go back to our dashboard, we now see that our pairs are now duplex because the arrow is green. The replication is still from site 1 to site 2. So if we want to fully complete our scenario, we would do an hyperswap back to site 1 and resynchronize our pairs again. So very similar to what we did. So in conclusion, we can say that GDPS has evolved over the years to provide more and more value while keeping the complexity of usage as low as possible. With the introduction of the graphical user interface and the RESTful API, the intent is to provide an intuitive and easy to use interface to lower the learning curve of GDPS and make it easier for our customers to get new people up to speed with IBM Z products. The GDPS RESTful API offers a standard programmatic interface that can be interconnected with all the other interfaces and extends the automation that you can build for your high availability or disaster recovery solutions. So thank you for listening to me and Anthony, and don't forget to provide your feedback. Thanks.
Yep. So if you can please provide your feedback.
Sorry, I see we have a question, and yes, GDPS provides samples. I don't know for IBM, but I know that in GDPS we provide samples in a lot of languages to use the RESTful API with GDPS.
You all have the ability now to unmute yourselves in order to ask any further questions. Okay, so if there's no further questions, then I will end the session as before. Please remember to give generously, get your raffle tickets from giving generously, and thank you to Anthony and Victor for very interesting presentation. I'll see a lot of you again later this afternoon.